everybody. We'll get started in just a minute. Okay, good morning, everybody. Today is our last day of lecture. We're actually just going to be reviewing today for the final exam, which is going to take place tomorrow. So tomorrow we'll have an exam just like we had before. I'll take the first, 15, 20 minutes of tomorrow to answer any questions. If we don't have any questions, then we'll get started right away. And that'll be it. That'll be our last meeting. And then I'll get your final grades posted. A little bit about the exam, some things that we need to clarify. So first of all, that the exam tomorrow only covers what we review today. All right, so that's all that will be on the exam is what we cover today. And then for tomorrow's exam, you may use a cheat sheet, right? Just like we did on the last exam. So that cheat sheet, remember on that cheat sheet that you can use, it's 1 8.5 by 11 inch. So standard sheet of paper, front and back if you want. But you can only have formulas on that, steps, etc. No worked out problems, right? That was the big thing. And then otherwise, I expect everyone to have their camera set up properly, just like before. Are there any questions on that? Any questions on the expectations?
Yeah, can we use a lined paper or does it have to be like blank?
No, it can be paper with lines. You could use graph paper if you wanted. I don't care what kind of paper, just as long as when you start the test, it's blank.
Okay, thank you.
Okay. Any other questions? Okay. All right, well, let's try and pick up where we left off. Last class, at the end of class, I gave you some problems to look at to see how you did with those. Were there any questions on any of these? We were trying to sketch these quadratic functions. So I wanted to do one of these at least to start. So does anyone have any requests for one of these? If not, I'll just pick one. No requests. Okay, let me do this one then. I'm just picking it randomly. It's not that this is any more difficult or anything like that. So, all right, so what we did last time, we kind of go back and remind you that when it comes to quadratic functions, we can see these in two different forms. We have the vertex form and we have the standard form. Last class, all we talked about was the vertex form and how we can use the vertex form to easily sketch the functions. So, and then what I had you doing on these was figuring out when the function opens or whether it opens up or down. I wanted you to find the vertex. I wanted you to do a sketch, find the axis of symmetry, and then also find the x-intercepts if you had any. So I'm going to take those same instructions and let's go ahead and do that over here. All right, so when we see this function, we need to realize that it does look like a, then parentheses x minus h squared plus k, and we just need to identify what everything is. So the a here would be positive 1/4. We do have a minus here, which matches the formula, so that means that our h, let me write this down, a is going to be 1/4. The h for this problem is 1, and the k is the number here on the outside, so the k is positive 2. Now, determining if it opens up or down, all we do is simply look at the value of a. Since a is 1/4, and that's a positive number greater than 0, that tells me that this opens up. So my parabola is going to look something like this, which means that it's going to have a lowest point, right? That point, it's going to have a point on the bottom, which we call our vertex. Now that vertex is just a point. The point is always going to be the point HK, which is why this vertex form is called the vertex form, because by looking at it, you can easily identify that the vertex would be 1, 2. That's where we would have that lowest point. So now what I do is I draw a quick little sketch here. And I'm going to use the vertex. I'm going to go to the right one, and I'm going to go up 2. 1, 2, right there. And I draw a point. That is going to be my vertex. And I know, again, that it opened up, right? So this thing is going to have to go like this and go up. And I'm done with my quick sketch there. Now, the axis of symmetry, I told you, is always x equals, and then it's just your h, whatever your h value is. So for us, our h value is 1. And I told you that that's kind of like an imaginary line that goes through the middle here like this. That's the line x equals 1. And our parabola, or our function, should look like a mirror image of itself over that line, which it does there. So the last question here is to figure out if this thing has any x-intercepts. Now, to find the x-intercepts, what we would do normally is we would take the function and set it equal to 0. And then I showed you how we solved that last class. But the thing is, I'm not going to do this because I can tell from my quick sketch over here that I have no x-intercepts, because you can see that this parabola doesn't open down. If it opened down, then it would hit the x-axis in 2 spots. But since it opens up, I have no x-intercepts. So I'm not going to waste my time trying to solve this equation. If you did, if you did do this work, you'd wind up getting something like x is equal to, and then you'd have square root somewhere, because you would have to take square root of both sides, and underneath here you would have a negative number. And because of that, it would be an imaginary solution, so we wouldn't be able to plot the answer. So you don't have any real solutions. So we have no x-intercepts. And that's all you do. Do you have any questions on that? Okay. So today what we're going to do is we're going to talk a little bit more about some terminology here. We're going to go back to something we did earlier when we were talking about functions. I would like to add a few more things to our questions here. So I'm going to add a 6th thing here. I want us to find the domain and the range of this function. So we have to go back and we talked about domain and range earlier. The domain are basically the things that are allowed to be plugged in, the inputs, and the range are your outputs. So I'm going to take a look at that graph again. I'm just going to do it real quick here. I went to the right one, I went up 2. There was a point and my parabola opened up like this. So when I figure out what the domain is, see if this rings a bell to you here. For the domain, what I'm doing is I'm looking at where this graph exists in terms of the X values. So like if I plug in 1, I get a point. Whoa, what happened there? If I plug in 1, I get a point. If I plug in 2, I get a point. If I plug in 3, I get a point. 4, there's some point way up here on this parabola. And that would happen no matter how far I go out to the right or to the left. I'm always going to have my X values, these inputs, right, can be any number I want. And I'm going to have some output for each input. So the domain of this function is everything, negative infinity to infinity. Those are all the numbers I'm allowed to plug into this function. Now, in terms of the output, what I do is I look at what Y values come out of this function. So if I start, looking down here in the negative part, if I look at these different Y values down here, my graph is never down here. And my graph is going to not exist until I get to a Y value of 2. That's where my graph finally exists. And then once I go up past 2 to 3 or 4, I actually have points on my graph. So, and that'll keep going forever as I go this way. So my outputs of this function go from 2 up to infinity, and it actually does take on the value of 2. So my range would be everything from 2 with a bracket on it up to infinity. So that's my domain and range. I hope that makes sense. We're going to do a few more examples of this. Let me do maybe 1 or 2 more of these. Let me bring up Desmos. Okay, I'm gonna graph something here. So let's say we have this quadratic function, f of x, equals -4 parentheses x plus 3 squared, and then plus 6. There we go. And I'll actually plot that point so it's a little easier to see. Go. So there's the 0.36, -3,6. All right, so there's my parabola. If I were to take this and ask you for this parabola, what's the domain and range? The domain of this would again be the X values where this function exists. Now for all parabolas, this is for all parabolas, this arrow implies that it goes forever. So this thing, no matter what X you pick here, like 3, I'm eventually going to have part of the graph way down here somewhere when this parabola widens out. Eventually, I'm going to have a point on the graph. And that's going to happen for every value of X we ever pick. We're going to have some graph. So the domain of all quadratic functions is -infinity to infinity. The part that you have to really pay attention to is the range. So for this particular one, I can see that if I start out any Y value I pick down here, my graph is going to be there eventually. And I can go down as far as I want. I'm going to have outputs. And I'm going to have Y values, outputs of the function, all the way until I get up to 6. And at Y equals 6, that's where I stop having graph. So the way I say that, when we talk about range on the y-axis, where we start from the bottom and go up. So this would be from negative infinity all the way up until I get to 6, and then I put a bracket on the 6. And that's it. Does that make sense? Are there any questions there? We're good? Okay. All right. So the last thing that we need to do today, before we start reviewing for the test tomorrow, the last thing we need to do is discuss the other form, the standard form, okay, and how we go about doing the same thing, drawing a picture and all that for a standard form. So let's begin. I'm going to begin with an example. So let's take f of x. I'm going to say if f of x equals x squared, let's go plus 6x minus 2. Right? And for this problem, what I want to do is let me list out the things I want here. First thing, I want to know if this this opens up or down. Second thing I want to know is what is the vertex. The third thing I want to know is if you can give me a quick sketch of this. The fourth thing I want is the axis of symmetry. The fifth thing I want is the x-intercepts. The sixth thing I want is the domain and range. All right. So we have a problem to start off, and that is that it's not in vertex form, right? So going back to last time, right? This vertex form was really nice because you could see the vertex easily, just H and K. You just look at it and visually identify it. Here in the standard form, we don't have H and K. The only thing we have in common between these two are the A's. The A is the same A in both formulas. So A, remember, determines if it opens up or down, the A value. So we can still use that here. I still know to answer part 1 that this is going to open up because the A value for us is the number in front of x squared is 1, and that's a positive number. So I know my parabola is going to look like that and have a lowest point. Now, the vertex is more difficult, all right? So I'm going to show you something, all right? In other words, I'm going to show you how to find this vertex, all right? And there's 2 different ways to do it, all right? There's 2 different ways to do it. And the first way I'm going to do it is probably not the way you're going to do it. I'm going to eventually give you a formula for this, but I want you to see where this formula kind of comes from. So what I'm going to do to find the vertex is I'm going to try and turn this into the other form. I'm going to try and turn this into vertex form. And to do that, I'm going to use completing of the square, which is something we talked about before. So I'm going to look at this right here, and I'm going to complete the square. Well, if you remember anything about completing the square, it's kind of a pain in the ass. So let me write it down. I have x squared plus 6x minus 2. The first thing we have to have for completing of the square is we have to have a 1 in front of x squared, which we have. So we don't have to worry about that. And now this is where you have to come up with those 2 magic numbers, right? You have 6. You look at the number in front of x, that's 6. You take that 6, you divide by 2, that gives you 3. I call that my first magic number. Then you take that 3 and you square it, and that gives you 9, and I call that my second magic number. And then what you did, or what we did, is we wrote down x squared plus 6x. And now we realized that there was a hidden 0 there. I hope that rings a bell. But the way we wrote that hidden 0 is by using that second magic number. I'm going to do +9 -9. And then I still had the -2 there. And then I put the first 3 together and I told you those are guaranteed the factor to be something squared. And it's always going to be x. And then you bring your first number in here. And since it's +3, I'm going to put +3. So those first 3 terms are x plus 3 squared. And then you still have a -11 over here. And this is our function. And if you notice now what we've done is we have put this into vertex form. This now looks like a times x minus h squared plus k. And for us, our h will be the opposite of what we see here, so -3. And our k will be this number here, which will be -11. You see how that works? It's very, the completing the square is very good at turning a standard equation, or sorry, the standard form of a quadratic into the vertex form. So I can now answer the question about vertex, right? My vertex is HK, which I found to be -3, -11. Any questions there? So for vertex, there are 2 methods. This is the first option. Option A, let's say, okay? And for this, what do? We completed the square. Now your second option, option B, is going to be what's called the vertex formula. This is actually a formula that we can prove is true in calculus 1. And here's the way it works. We take our function written in its standard form. What was it? -2. Okay. And here's what we're going to do. We're going to use a formula. And this is a formula you can put on your formula sheet or your cheat sheet. Here's the vertex formula. I'll do it on the side. The vertex formula says this. If you want to know what h is, it's always going to be -b divided by 2a. -b divided by 2a, always. Now, you don't need to worry about why. Again, I said that's something we would prove in calculus. So it's a formula that allows you to just generate what h is. And then once you find that h, to figure out what k is, all you do is you take your function and you plug that value h into the function. And whatever comes out is your k. So let me show you that on this problem. And remember that here, a is 1, right? In this problem, a is 1, b is +6, and c here for us is -2. Right? That's what a, b, and c are. So to find h, all I need to do is take -b, and for us b was 6, and divide that by 2 times a, but a was 1. So the a here is 1, and the 6 came from there. So just plug those numbers in, and you'll see here that you get -6/2, which is just -3. And that already matches, right? That already matches what we got earlier, right? This -3 matches. So far, it's right. Now to get k, what we do is we take the answer we just got, -3, and we plug it into the function. So that means I need to plug it in for x. So I'm gonna have -3 squared plus 6 times -3 and then -2. So all I'm doing is plugging that into the function and I should get my k. So -3 squared is 9. 6 times -3 is -18, and then -2, and that should give me -9 minus 2 is -11. And that again matches my vertex from before. So either one of these options works. You pick the one that you want. Most students wind up just going to the vertex formula, because completing the square can be a little tricky, especially if we've got some weird, like if we had a number in front other than 1, then we would have to do some more work. All right. Let me get back to the question here. So we found the vertex. Okay, let's do a quick sketch of this. So to do a quick sketch, I go -3, 1, 2, 3, there's -3, and I go down 11. So let's just say -11 is somewhere down here. And I put a point there for my parabola, that's my vertex. And now remembering that this thing opens up, I know it's gonna go up like this, it's gonna go up like that, right? And that automatically tells me I'm gonna have 2 x-intercepts, right? I don't know where they are exactly right now, but I know that they're there somewhere. The fourth step, my axis of symmetry. This is the easy one. The axis of symmetry is always just the h, right, off your vertex. So x equals -3. That would be an imaginary line that goes through the center right there. That's this. And now I'm going to see if I can move that down a little bit. Let me move this down just a little bit. Okay, yeah, that'll work. Okay, so now I've got that. The fifth step. All right, the fifth step is not going to be the fun part. This is going to be a little bit of trouble. So the fifth step, I need the x-intercepts. And to find the x-intercepts, what we do is we take the function and we set it equal to 0. That's the way you find the x-intercepts of any function. So that means I need to take x squared plus 6x minus 2 and set it equal to 0. And this is a quadratic equation. And because we have a quadratic equation, going back to last class, let's see where I have it here. No, those are different. It's actually from 2 classes ago. Here we go. Remember how we solved quadratic equations? We had all these different options, right? Square root property if we're missing an x term. Factor out a GCF if you only have x and x squared. You can complete the square, but this was tedious. We didn't like it. And then we had the quadratic formula that always worked, right? So it's now up to me to determine how I'm going to go about this. I always like to see if the AC method would work, where you go here, multiply to here, that's -2. And then the number in front here of the x is 6, and you're trying to find 2 numbers that multiply to be this, but add to be this. Unfortunately, you're not going to be able to find 2 numbers that do that. And if you can't find 2 numbers that do that, then you're really just left with completing the square or the quadratic formula. So I'm going to go with the quadratic formula here, which remember is x is -b plus or minus the square root b squared minus 4ac, all of that divided by 2a. So for us, -b is -6 plus or minus the square root. B squared, b is 6, so square that, you get 36 minus 4 times a, which is 1, times c, which is -2, And then all of that divided by 2 times 1. And now I'm going to just keep going. Here's the -6 plus or minus square root. Okay, underneath that root, I see that I have 2 negatives, which means when I write this out, I'm going to do 36. 2 negatives will become a positive, so it's going to be plus. And then I do 4 times 1 times 2, which is 8. All over 2. And then this is -6 plus or minus, okay, square root of 44. It's 36 plus 8, then over 2. Now, in the past, that would be sufficient as an answer. But we're trying to find the place on the x-axis where to put these dots for the x-intercept, right? We're trying to figure out these 2 places, and this is giving us the answers to where those hit the x-axis. So I'm actually going to get my calculator out now, and I'm going to figure out what the square root of 44 is. And according to my calculator, the square root of 44, so I'm putting -6 plus or minus, the square root of 44 is about 6 point, I'm just going to say 6.6. And then all divided by the 2. So notice I don't have a square root anymore because I use my calculator. Okay. Let's keep going. This equals, now I have 2 different scenarios, the plus scenario and the minus scenario. So if I use the plus sign, it's -6 plus 6.6 all over 2. If I do the numerator together, add those up, I'm going to get 0.6 divided by 2, which equals 0.3. And then if I do the minus, it's going to become -6 minus 6.6 all over 2. The top becomes -12.6 over 2, and this becomes -6.3. So I have 2 decimal answers for my x-intercepts, 0.3 and -6.3. And I think that that matches up pretty good. If we were to come back and draw this graph again, which we don't have to do, I'm not asking you to do that, but imagine that you plotted these points. What we're saying is that this point is -6.3, and this point was 0.3. So even with my just rough sketch, I was pretty close to the answer. I just kind of got lucky there. Okay. There's a lot there, right? Are we done? Oh, domain and range. Sorry, didn't do domain and range. I'll squeeze domain and range in right here. Trying to get everything on one screen. For domain and range, that's what we just talked about again. For quadratics, the domain will always be everything. And the range here, I can see that my graph starts at -11 on the y-axis and goes up forever. And that's it. So what we've seen here for this, right? What we've seen is that if we're given something in standard form, we can answer all the same questions, right? Oops. Hang tight for a second. Okay, sorry about that. My wife knows I'm in class, so she called and thought there might be an emergency, but of course not. All right, here we go. We are going to, let's do one more example, okay, together. And then I'm going to give you an example. All right, and I want to do another one of these standard form because they take a while. And you know what, let me see on this review if I'm ready to give you this. Yeah, not yet. Okay, not yet. All right, so for this problem here, let's take f of x equals, let's go with negative 3x squared plus 12x minus, no, let's make it plus 10. Yeah, 10. All right, there we go. So I want to do the same thing that we did on the last problem. Let me just go copy that real quick. I want these things. So first thing, I want to know if it opens up or down. Well, let me just identify real quick. A here for us is -3. B here for us is 12. And C here for us is 10. So I can tell that it opens up because, I'm sorry, not up, it's down. It opens down because A is -3, which is a negative number, right? So we know my graph's going to go like this, which means I'm going to have a highest point, not a lowest point. The next thing is for me to find the vertex. Now, let's go with the formula, okay? The vertex formula. First thing I'm going to do is I'm going to use the fact that h must be -b over 2 times a. For us, b is 12, so -12 over 2 times -3. Hey, be careful on that vertex formula, this -b. If b was already negative, then it would become a negative, which is positive. So if this had been -12, then that would be +12 up there because you're doubling the negative. So look at that -b on top is really saying, what's the opposite of b? For us, the opposite of b is -12. I divide that by 2 times a was -3. This becomes -12 over -6, and that becomes +2. +2. Now, to get k, what we have to do is we have to take that answer 2, plug it into the function. So -3 times 2 squared plus 12 times 2 plus 10. And just make sure you take your time with this, do things correctly. This is -3 times 4 plus 24 plus 10. What's that? That's -12 plus 24 plus 10. That should give us, I believe, 22. So my vertex, right, is the point 2, 22. That's my vertex. The third thing is a quick sketch. So I'm going to do a very quick sketch here. I go to the right, 1, 2. I go up 22, way up there. I put a point, and I know that my parabola opens down. So it goes something like this. That is really just to tell me whether or not I have x-intercepts or not. Here I can see I'm going to have 2 x-intercepts. Okay. All right, I have 2 x-intercepts. Let's answer the fourth part here. Axis of symmetry. Well, that's just x equals 2, going back to the idea that it's always just h. It's just vertical dotted line like this. The fifth part, the x-intercepts, is the part that's going to not be fun. So -3x squared plus 12x plus 10 equals 0. I could, if I want, again, try the AC method. I don't think it's going to work. If I take -3 and multiply by 10, I get -30. And then the number in front of x is 12. I do not believe there are 2 numbers that multiply to be -30. and add up to be 12. It's pretty close, like 15 and 2, right? I could do like 15 and -2, those multiply to be 30, but they add up to be 13, not 12. So that's close, but it doesn't work. So nothing's going to work. All right, you can try other numbers, but I always look at that first, because if that works, I can factor easily. I don't need the quadratic formula at all. I don't feel like completing the square, so I'm going to go right to the quadratic formula. Right, x equals, and this, of course, you'll have that on your cheat sheet, right? I'm not going to provide you the quadratic formula, so make sure you put it on your reference sheet. So here we go, negative b plus or minus the square root. All right, b squared is 12 squared, that's 144, minus 4 times a, be careful, there's a negative there, times c, which is 10. And all divided by 2 times -3. I look real quick, I've got negative and negative. That means I'm going to have a positive there. So, or a plus sign, I should say. So 144 plus. All right, now I just multiply these numbers together. 4 times 3 times 10. So 4 times 3 is 12, times 10 is 120. And then over 2 times -3, be careful, that's a -6. This equals -12 plus or minus the square root of, okay, 264. When you add those up, over -6, I'm going to get my calculator out. I'm going to do the square root of 264. And remember, the reason I'm doing this is because I eventually would like to know what these are on the x-axis, what points they are. And if I leave it as a square root, I probably won't be able to convince myself that these answers are right. So let me put here, I'm going to go 16.2. I don't really care too much about the rounding on that. So I took the square root, I got 16.2, and now I have 2 different answers to look at, the positive and the negative. So if I do the positive, it's -12 plus 16.2 all over -6. I'm gonna run out of room there. Let me do something. Let me just move this over here a little bit. So yeah, -12 plus the 16.2, then over -6. And I'm just going to get on my calculator and do that. On the top, you get 4.2. And on the bottom, -6. So divide by -6. And you get negative 0.7 or -0.7, however you want to put that. And then on the other one, it's -12 now minus the 16.2. We're taking that other case over -6. Go ahead and do that on my calculator. That's -28.2 over -6. We get 4.7. Okay. Last thing is domain and range. I'll squeeze that in right here. The domain of all quadratic functions is everything. The range, well, if you look at this, parabola opens down. So it should, on the y-axis coming up from the bottom, it's -infinity all the way till I get to the highest value on the y, which is 22, and then put a bracket on that. And that's it. So what I'm going to do right now is I'm going to check our answer by doing this. I'm going to come over to Desmos, and I'm going to first put the vertex we got, which was 222. And then we got our 2x intercepts, which were negative 0.7 and 4.7. Okay, so those are my two x-intercepts. I'm going to put that axis of symmetry. So we should have a parabola that starts here, goes down through there and there. Now, let's use the computer to actually get us the answer. It was negative 3x, oops, 3x squared. I forgot the negative. This is just checking my work, that's all. Plus 12x plus 10, there it is. So you can see that I have the correct parabola here. All right. I think that's it. I think I want to give you one to do. All right. So what I'd like for you to do here is, those are pretty straightforward. I want you to follow the same instructions. I'll zoom out here so you can see this. I think that's all my work right there. I want you to do the same thing, but let's do it for this function. I'll put it over here on the side. I want you to do it for, or I'll put it, where can I put this? I'll put it up here at the top. I want you to do f of x equals, let's do 2x squared minus 8x. Let's go minus get out minus 5. Yeah, that's it. Okay, I want you to go through and do the same 6 things. All right. Does it open up or down? What's the vertex? Quick sketch, axis of symmetry, x-intercepts, domain and range. And let me know when you're done. I'm going to give you like probably 10 minutes to do this. It's going to take probably a little while to get this all done. Okay, we have 4 students say they're done. I'm gonna go just another minute or so. I'm gonna show my work. Okay. Well, 6 of you are done. Take a look there at that work, see if there's anything that you might have questions over. Anything here? I actually made a mistake first time I did it. I messed up my K. What I did was when I copied the problem down, I accidentally put a plus there right here instead, and that messed everything up. So just be careful when you're putting things there. Make sure you look at the right signs. So no questions? Okay, let's talk about the test. All right. We're going to start here with one of the documents I sent out to you last week, or was it last week? This weekend? Yeah, at the end of last week. And this is an old review, and we are going to start reviewing right here. It was number 20, I think. Oh, no, number 15. So this is where we're going to begin. All right. I'm going to start working these out. I'm going to work out the rest of this, and then we're going to talk about the final review. And then we're done. That's pretty much it, because I've decided this last test is not going to be like super cumulative over the whole semester. And remember also that I've said that whatever grade you get on this test can replace your lowest grade, right? But you have to have taken, like if you just didn't show up for a test and didn't take the test, that's a different scenario. But if you showed up, took the test, you didn't do that well, this final can replace that grade. All right. So let's do this. Let's start with these. So just if you're looking back in our book or in the ebook and you want to know what section this was over, this is what we're doing right now. Back up here. Actually, let me do it this way. Let me bring up your calendar. That'll be easier. So what we're doing right now is multiplying and dividing radical expressions. So this is going to be here at the end of chapter 18. If you're going back, we didn't quite get this on that second test. So that's what I'm going to do now. So where the hell is it? Okay, here we go. So we want to multiply these two radicals together. So here, to multiply these two together, all we do, since there's multiplication, there's a property that says that we can put these together and multiply the two. And that just gives me square root of 150. Now, what we do want to make sure is that that can't be simplified. All right. In other words, we want to go back, and since it's a square root, we want to look at our perfect squares, right? Where this list 1, 4, 9, 16, 25, 36, 49, 64. And we want to see on that list, do any of those numbers go into 150? And you can just get your calculator if you can't figure it out, just by looking. Take your calculator, start dividing it by these numbers, and until you get to about half of this number, half of that number 75. So when you get to about that number, you can stop. So the next number we would have had was 81. If you try these, do any of them work? Oops.
25.
25. Yeah, 25 goes in there. Good. So we would have to realize that this is the same as the square root of 25. 25 goes in there 6 times. And then we can break this up into 2 roots, root 25 times root 6. And the square root of 25 is 5, and then times root 6. Root 6 can't be broken down because none of these numbers in here go into 6. So that would be our simplified version. That's one way to do it. Another way to do it, okay, another way to do it would have been to go back up here and break 15 down to be 3 times 5, break 10 down to be 2 times 5. And then when you put these together, it's 3 times 2. Sorry, let me do it this way. It's 3 times 5 times 2 times 5. And then you can see that we have 2 5s in there. We have a group of 2. So when we can split this up as to the square root of 5 squared, square root of 2 times 3. And then the root and the squared cancel, and you get the 5, and then this is just 2 times 3 is 6. So either way works. I think I showed more of like this way. All right, that's the first one. Now the second one, we need to multiply here. So we have multiplication, and we have parentheses, and we have addition in between. We cannot put these 2 roots together because they are not like radicals. They would have to have the same number underneath, so we can't combine those. But what we can do is we can multiply here and here, like a distribution. So I'm going to go root 6 times root 2, times root 2, and then plus, and then root 6 times root 3. This is the same as root of 12, 6 times 2, plus root of 18. And then we're going to play that same game that we just played with this list of numbers. And notice that 4 goes into the first one 3 times. So that's root 4 times 3. And 9 goes into this one 9 times 2. And so you can break this up to be root 4 times root 3. And this one root 9 times root 2. Square root of 4 is 2 root 3. Plus square root of 9 is 3 root 2. And you cannot combine those because, again, they don't have the same radicals. They both have a square root, but they don't both have a 2. If these both had 2 under here, then we could add them together. If they both had 3, we could add them together. But here, because they're different, we're done. So please be aware that on this test, if you give me this answer, yes, you have multiplied, but you haven't simplified. So you've got to take it all the way to here. Same with this one. If you give me root 50, root 150, you're only like halfway there. Questions? All right, on this next one, we have to multiply again, but now we have 2 terms and 2 terms. So we're going to have to do like a FOIL. We have to go here to here. Let's do that first. 2 root 3 times 3 root 3. And then 2 root 3 times that, there's a negative there. So it's going to be negative 2 root 3 times root 2. And then we go the middle ones. That's going to be positive 5 root 2 times 3 root 3. And then finally, this will be a negative because one of them is positive, one of them is negative. 5 root 2 times root 2. All right, that's a lot going on there. So let's see what happens here. On the first one, I can put the 2 and 3 together to give me 6. And then I have root 3 times root 3. Remember, root 3 times root 3 is the same as root 9, and that's just 3. So the root basically goes away. So this is just 6 times 3. And then minus, now here, the 2, I'm going to leave, and then I'm going to put these 2 roots together, multiply, which means you put them into one root, multiply 3 times 2, get root 6. On the next one, I'll do 5 times 3, that's 15, and then I'll put these 2 roots together again, gives me root 6. And then finally, I have on the last one, the 5, and then those 2 roots come together to become a root 4, which is just 2. So this is just 5 times 2. So we get 18. I can put these 2 together because they're both like radicals. They both have the same root, same number underneath. When we add those up, we just look at the numbers in front. -2 plus 15, that gives us 13 root 6s. And then at the very end, minus 10, 5 times 2. And you can put the 18 minus 10 together and get 8, right? Those 2. And then plus 13 root 6. Can't do anything with that. Please don't turn this into 21 root 6, right? That's not right. You can't put the 8 and the 13 together because they're not like terms. All right, questions here? Okay, let's look at the next set of problems here. See if I can get all these together. There we go. Let's try that. We'll do these and then we'll take a break, okay? All right. So on this first one, we're using the quotient rule. So we're dividing radicals. So the property we have here is that we can turn this one into 1 root 147 divided by 3. And then just go on your calculator and hope that that turns out to be something you can do. 147 divided by 3, well, that's 49. So this is the square root of 49, and the square root of 49, that's a perfect square. So we know that that's going to be 7. All right, on the next one, we're going to do the same thing. Notice we have a 4th root, not a square root, right? 4th root, I'm going to put 80 k to the 37th over 5k to the 17th. Now, 80 divided by 5 is 16, so I have 4th root. I have a 16 there. And then to put these 2 together, we subtract the exponents, right? 37 take away 17. If we do that, we should get k to the 20th power. Now I'm going to split this up. I'm going to do the 4th root of 16 times the 4th root of k to the 20th. I didn't put a k, sorry. K to the 20th. The 4th root of 16, we have to recognize the 4th root of 16 as 2, because 2 times 2 times 2 times 2 is 16. That would, you could write down the 4th powers on your cheat sheet if you wanted that reference, right? And then on the next part, there's several ways to look at that. The way that I showed you in class to do this is convert this to rational exponents. So that's k to the 20 over 4. And I'm doing that because I realized that 4 goes into 25 times. So this is really k to the 5th power. So next to this, I have no more root. It's just k to the 5th. And I'm done. Now, out of curiosity, just to show you, what if this had been the 4th root of k to, let's say, the 22nd power, not the 20th. Let's just say that's what it was. then what I would do is I would say, okay, how many times does 4 go into 22? Well, it goes in there 5 times, right? Without going over. So I would break this up into the 4th root of k to the 20th times the 4th root of k to the 2nd power. And then here, I already know that this turns into k to the 5th. That's what we just did. And then over here, I cannot do anything to this because the root on the outside is bigger than this number. So I'd just be done there. Any questions on those two? Okay, rationalizing the denominator. This goes back to an idea that I told you about, that we often don't like to have radicals in the denominator. So when we have something like 6 over root 7, the way we get rid of that is to multiply the top and bottom by root 7. And what happens is on the top, you get 6 root 7. On the bottom, root 7 times root 7 is root 49. And that's just 6 root 7 over 7 because root 49 is 7. So we're done. The idea of rationalizing is to not have a square root in the bottom at the end. On the next one, I have 2 root 3 over root 10. Again, I don't want a root on the bottom, so I multiply top and bottom by root 10. On the top, pay attention here because you'll have the 2, and then the root 3 times root 10 gives me root 30. And then over on the bottom, you just get 10, right? Root 10 times root 10 is root 100, and square root of 100 is 10. And then there's one more thing we can do. We can reduce this fraction. 2 goes into 2 once, 2 goes into 10 5 times. So you wind up with root 30 on top, and then on the bottom 5. Again, we have written it now where we do not have a root on the bottom anymore. Questions there? One more. Let's do this last one. Yeah, let's do this last one here, and then we'll take our break because then we'll switch topics. So last one here. Again, we want to rationalize the denominator, so we don't want a root in the denominator. The difference between this problem and the last problem is that we actually have 2 terms down here instead of just 1. And because we have 2 terms, this is the special case where we have to come in here and multiply by the conjugate of the bottom. The conjugate is the same thing we see on the bottom, but with the opposite sign. So instead of 4 minus root 2, I put 4 plus root 2. Had this been a plus, I would have put a minus here on top and bottom. Now we have to multiply this out, and unfortunately, this is gonna be a little tedious. So on the top we FOIL, so 5 times 4 is 20, and then 5 times positive root 2 is going to be positive 5 root 2, and then positive root 2 times positive 4 is positive 4 root 2, and finally root 2 times root 2 is square root of 4. I'll just go ahead and put that square root of 4. That's going to turn into a 2. All of that over. Now I do the same thing on the bottom. 4 times 4, 16. And then the next 2 multiplications are going to cancel each other out. When I do this times this, I get positive 4 root 2. But now when I do the middle one, I get negative 4 root 2. And those are always going to go away, which is why we do this. And then I do the last multiplication. Negative times a positive is negative. Root 2 times root 2 is root 4. We're almost done. On the top, remember this root 4 is a 2. That root 4 is a 2. So when I do that, I can put the 2 and 20 and 2 together to become 22. I can also combine these two because they're both like radicals. So that becomes 9 root 2. And then on the bottom, I have 16 and then minus 2. That's going to give me 14. There we go. All right, I'm gonna end the poll. And I'm going to relaunch the poll. I'm not asking you any questions. That's just so I have a timer. All right, let's take like a 5-6 minute break, and then we'll come back. We'll finish up the rest of this part and then start the final exam review. Okay. Let's continue our review. So we've got 3 more problems to do here, and then we'll be done with that one document I sent you. Then we'll start the actual other document. All right, so the first question here, number 23, is asking us to solve this radical equation. So we have to go back and look, where does this occur? Again, you can go look this up. Solving radical equations was 18.7. All right, so everything we're doing right now is kind of the tail end of chapter 18. So solving this radical equation, the first thing we want to do, there were a set of steps we had. So the first step was to isolate the radical. So we want to get this by itself. All right, so first thing I'll do is subtract 8 on both sides. That'll make it go away. I'll have square root x to the 11 equals, and then take away 8 from 15, and I get 7. And the next step is to square both sides. And you do that so that you can get rid of the square root. So when you square the square root, they go away, you get x plus 11 equals, and then 7 squared is 49. And finally, you will subtract 11 on both sides, and you get x is equal to 38. But we have to check our answers. We only have one answer, but we have to check it. The reason we have to check it is because we squared both sides. And remember, we said if you ever raise both sides of an equation to an even power, you have to check your answer. So let me check it. When I check it, I do square root. Let me plug in 38 plus 11 plus 8. See if that's equal to 15. So that is 49. Square root of 49 plus 8. Does that equal 15? Well, square root of 49 is 7. 7 plus 8. Yes, 7 plus 8 is 15. That works. So that is my one solution. Now in the next equation over here, I notice I have cube roots, right? And I do want to try and isolate. Oh, by the way, everyone, I might get a phone call that I have to take from my dog's vet. I'm still having problems with my dog. So I called, they said they were going to call me back. So I apologize ahead of time. If I get a call, I may just mute myself, go off camera, and deal with that real quick. Okay, so the idea here, again, get a root by itself. Well, there's 2 roots, so it doesn't matter which one I get by itself. I'm going to just say, look, the one on the left is by itself. So once it's by itself, I can just cube both sides, and I'm doing cube so I can undo the cube root. On the left-hand side, the cube root and the cube go away, get 7n minus 5. And lucky for us, we have cube root and cube again on the right side, and everything goes away. We just get 2n plus 25. Now just solve for n. So I'm going to subtract 2n here, subtract 2n here. That gives me 5n minus 5 equals 25. I'll add 5 to both sides, trying to get that n term by itself. 5n equals 30. Divide both sides by 5, and you get n is equal to 6. Don't have to check our answer here because we raised both sides to an odd power. You could check it though, it would work. All right, the last one, any questions there? The last one here is the one that is, well, this one's just going to turn out to give us a quadratic equation. So let me isolate the root first, which it is isolated. Since it's isolated and it's a square root, I'm going to square both sides. The left side is just x plus 3. That's the nice part. But the right side, you actually have to square this whole thing. So you have to do x minus 3 times x minus 3. And then you have to do your FOIL. Now, I'm not going to show that work. I'm just going to show you what you would get. Okay, that's what you would get if you squared the right side. Just be careful. The big mistake I see students make on tests is that they'll turn that into x squared minus 9. And that's not right. What you're doing there is just squaring each term. That's not the way we square a binomial. We have to FOIL it. So that's wrong. Now this is a quadratic equation. I'm going to try and move everything to one side. So I'm going to subtract x, subtract 3, subtract x, subtract 3. This gives me 0 on this side. Over here I have x squared minus 7x and then plus 6. I'm going to write that a different way. I'm going to just put it the other direction. I'm going to do it like this. It's the same thing. And now I have to solve a quadratic equation, which we just went through all the different ways we could do this. I believe this is going to go with the AC method. I could use the quadratic formula, but I think AC is going to work. Two numbers that multiply to be 6 add up to be -7. How about -6 and -1? I think that, yeah, that works. And if I do that, then I don't need to go through quadratic formula. I get my two factors. And because this was a 1 in front, I don't need to worry about doing that whole divide through thing. Set each of these equal to 0. And we get two solutions, 6 and 1. So it looks like I have two answers. However, remember, we squared both sides, which means I have to check my answers. So let me check. I'll check up here. Let me start with x is 6, see if it works or not. So I'm going back to the original problem. Let me put the original problem here. Before I did anything and squared anything, and there's the original problem. Let me replace x with 6. I get square root of 6 plus 3. Does that equal 6 minus 3? Well, 6 plus 3 is 9, so square root of 9. Does that equal 3? Yeah, 3 equals 3. We're good. So checking 6 works. That is a good answer. Let me check 1. So if I replace the x with 1, I get 1 plus 3 equals 1 minus 3, right? I'm checking this one now. And that gives me root 4 is equal to -2, and that is not true. The square root of 4 is not equal to -2. So I would throw that answer out. So I only have one answer, 6. Okay. All right. Moving on. So here's what I'm gonna do. Y'all are here, hopefully paying attention. Your final exam, you see this number, this says number 1 here, and there's 1, 2, 3, 4, 5 problems that are exactly the same type of problems. I'm going to do one of these, and I promise you that on your final, the problem you see is going to be one of these 4 that I didn't do. All right. What I'm telling you is that your final exam, this question is one of these. I'm just not telling you which one. All right. So I would like to take a request here. Someone can just tell me in the chat. Let me copy this. So somebody in the chat, pick the one that you want me to do. All right. That you would like me to do. Let's call this 1A, B, C, D. First come, first serve. So somebody in the chat, which one would you like me to do? Okay, E's been chosen. All right, so for E, we're taking 6x squared equals 9x plus 10. Okay, so y'all understand what I'm saying here? Your exam that you're going to take tomorrow, I'm going to ask you one of those questions. I'm not going to tell you which one, but one of those. So my advice would be do them all, practice, right? Be ready. Okay, I need to solve this. They're saying solve it by factoring. You see that? I actually do not care how you solve it. I'm not going to tell you to do it a certain way, all right? But because they're saying factoring here, I'm going to do that. So first thing I'm going to do is bring everything over to one side of the equation, make it equal 0. So basically I subtracted 9x, I subtracted 10 on both sides, right? And that's what I get. Now I'm going to try factoring. First thing I look for is a GCF. And I notice that I do not have a GCF here. I can't pull out a greatest common factor. So since I can't pull out a greatest common factor, I'm going to do the AC method. 6 times -10 is -60. And then -9. So I need to come up with two numbers and multiply to be -60 and add up to be -9. How about somebody in the chat or unmute yourself? Tell me what the two numbers are. If you can find them. If possible. So let's see, 1 and -60 is possible, or -1 and +60, but neither one of those add up to be -9. Let me try 2. Let's see, 2 and -30, or I could do -2 and +30. Doesn't work. 3 and -20, or -3 and +20. Doesn't work. How about 4? 4 and -15, -4 and +15. That's close, right? How about 5? 5 and what?
12.
12, -12, or -5 and +12. Those don't work, do they? So 6 goes in there -10 times, and -6, +10. That doesn't work either. 7 doesn't go in there, 8 doesn't go in there, 9 doesn't go in there, 10 doesn't go in there. So on this problem, they would want to say here that it was prime. All right. I don't know if you remember, before we got the quadratic formula, if we couldn't come up with the two numbers, if the two numbers didn't exist, we would say it's prime. On your exam, any quadratic equation I ever give you, I expect you to get the answers. Okay. So that's why on your instructions, I'm not going to tell you factoring. I'm just going to say solve. Right. So even though we can't do this, right, this doesn't work, we know that there are solutions to this because the quadratic formula guarantees we can find them. So I'm going to go to the quadratic formula now. X equals, and I've written the formula down enough, I think. A is 6, B is -9, and C is -10. I'm going to use the quadratic formula. So -b would be -9, plus or minus the square root. B squared is -9 squared, minus 4 times A, which was 6, times -10, all over 2 times A, which was 6. And now I'm just going to crank this out. So -9 is 9, plus or minus the square root. Okay, -9 squared is 81. I see that I have two negative signs, so it's going to become a plus. And then I have to, unfortunately, do that. That should be multiplying those together. I should get 4 times 6 times 10. 4 times 6 is 24, and then times 10 is 240. And then all of that over 12. And that's going to be 9 plus or minus the square root 321 underneath there over 12. And on your exam, I'm completely okay with that answer. I do not care on the exam for you to simplify that. That's okay if you just leave it like that. Now, unless it says like square root of 9. If it's square root of 9, of course, turn it into a 3. But if it's something not obvious, then just leave it. Okay, so on your test tomorrow, I promise you I'm going to give you one of these 4 problems. It may or may not factor, but even if it doesn't factor, you have the quadratic formula or the completing the square, but I think most of you are going to want to do the quadratic formula and not complete the square. All right, that one's done. Any questions? All right, next set of problems. Same thing here. I'm going to let you choose, and then I'll do on the test. I'll give you one of the ones you don't choose. So someone pick, chat or unmute yourself. Which one do you want me to do? B. All right, B got chosen here. So we're going to do this one. All right, so I have 1 over 24x squared minus 1 over 12x minus 1 equals 0. All right, this is a quadratic equation, right? The problem with this quadratic equation is that if you look at the numbers, right, we've got fractions, and we don't like fractions, right? So you could go use your AC method or try your AC method, or you could even use quadratic formula, but nobody here wants to work with fractions. So my recommendation on this is to clear the fractions, which means look at your denominators, 24 and 12, and find a least common denominator. So a number that is a multiple of both of those. And I think 24 works, right? 24 is 12 times 2. So you take the number 24 and you multiply it on both sides of the equation. And then you distribute it through over here. The right-hand side is just 0, because 0 times anything is 0. But the left-hand side, when you multiply that first multiplication, right, the 24s cancel, you just get x squared. On the second multiplication, you're going to get 24 over 12. That's going to be 2, so you have minus 2x. And then on the last multiplication, you get 24 times -1, which is -24. And now we have a new equation. It looks different, but the solutions to this equation are the same as the solutions to the one with the fractions, but much nicer numbers. Now I'm going to try my AC method. I'm going to cross my fingers here, hope this works. I get -24 there. I need 2 numbers that multiply to be that and add up to be -2. Does that work? Somebody tell me in the chat what the 2 numbers are. If you can figure them out. What 2 numbers multiply to be -24 add up to be -2? Okay, yes, I've got -6 and +4. Very good. Now, that will turn this into 2 sets of parentheses equals 0. I have x, take away 6, x, add 4. And I don't have to worry about the 1 in front, right? Set each of those equal to 0. You'll get 2 solutions, 6 and -4. You do not need to check these answers because we never squared both sides of an equation, right? Okay, good. Let's look at the next one. Same idea here. I'm going to have somebody pick A, B, C. We want A, B, C, D, or E.
C.
Okay, C. We have T to the fourth minus 3t cubed minus 11t squared plus 33t equals 0. All right, I want to solve this equation. And the first thing I notice is that it's got a fourth degree on it, right? It's not a quadratic. And now I start looking, okay, is there GCF? Is there a greatest common factor? Is there something I can pull out of all of these? Is there? There's a T, right? Can't I pull a T out of every single one of these? So I'm going to do that first. T, this will leave me with T cubed minus 3t squared minus 11t plus 33. Don't forget that step. Always remember for factoring, always pull GCF first. Now, what's in the parentheses, let's just focus our entire attention on what's in this parentheses and try and factor that. And I noticed that it has 4 terms. And because it has 4 terms, I'm going to try and do grouping. Right? Remember the grouping where we look at the first 2 and the second 2 and we try and pull GCF? Oh, I got something on my eye. Hold on. Okay. All right. So here we go. T is here. Here's my parentheses equals 0. Now, out of the first 2, I notice there's a t squared. So I can pull a t squared out of those. And what that would leave me here with is a t minus 1. Oh, sorry, t minus 3, not minus 1. Then I look at the second set of terms, and I'm going to see, is there something I can pull out that would leave me with the same thing, t minus 3? And I look at that for a little while, and I realize it's minus 11. Negative 11, right? It has to be negative because if you multiply this through, you get a negative 11t, and then here you get plus 33. I hope this looks familiar to you. Now I have this. Because these 2 things match, right? The whole idea behind grouping is now what I can do is I can write t minus 3 in parentheses, and then in another set of parentheses, the 2 things that were in front, t squared minus 11. And because I've factored that now, I don't technically need all those parentheses. I can just do this. Any questions up to that point? We're not done. Okay.
Sure.
Yeah.
Why would there not be a like, why isn't it t minus 3 squared?
T minus 3 squared.
Like,
I'm not
because it's t and then in parentheses t minus 3 and close parentheses. Why is that first parentheses not squared?
Where are you talking about? Right here?
Yeah.
Okay. So this goes back. I think what you're having trouble with is why this turns into this, right? Is that my understanding?
Yes.
Okay. So let's go back. Let me write something down here. What if I wrote this down? T squared y minus 11y. Okay. What if I wrote that down? What do you see there is a GCF, or do you see a GCF in those? Do you see something they both have in common?
Why?
Y. So if you were to factor this, you could pull the y out front, right? And then what would you have in that parentheses?
T squared minus 11.
T squared minus 11. So you understand that, right?
Yeah.
Okay. What you need to see here is that when we're at this step, this y, right, is just something, right? It's just something that matches in both of them. And so we pull that out front, right? We pull it out front. In this problem, the t minus 3, that's the y. See, that's like the y, and that's the y. And so what we do is we pull that out front. There's your y pulled out front. And then in the parentheses, you still have the t squared minus 11, just like you told me I would. Does that help a little bit, Joseph?
Yes, sir, I understand.
Yeah, that's the most difficult part to understand as a student, is that you're actually pulling out not just one thing, but the entire set of parentheses. The t minus 3 is the thing being pulled out. And that's why it's just by itself and not squared. I think you understand it, but back here, let me go back to this over here. When you pulled out that y, right, you didn't pull out y squared. You pulled out y. So that's why it's just a t minus 3. Okay, any other questions? We're still not done. All right, now what we have to do is we have to solve this, and we have a bunch of things being multiplied. So I'm going to set each of these equal to 0. T equals 0. Next equation, t minus 3 equals 0. Next equation, t squared minus 11 equals 0. All right, the first equation's already solved. T equals 0 is one solution. The next equation, I just add 3 to both sides. T is 3. The last equation is the one that's a little tricky. Because it's a squared, what I'm going to do is I'm going to add 11 to both sides. Okay. And I did that because now I can take the square root on both sides. And remember that when you do a square root, you have to do plus or minus square root of 11. The left side becomes a t. The right side is plus or minus the square root of 11. We actually have 2 answers there. So we have a total of 4 answers. T equals 0, t equals 3, t equals plus root 11, and t equals minus root 11. Those are our 4 solutions. This is a good problem, right? It requires a GCF, requires grouping. Once you do grouping, now you've got to solve this little quadratic that takes a little bit of work. So you will have something, one of these others, okay? Make sure you work through those. Any questions before I move on? Let's look at the next set here. Let's get a request here. A, B, C, D, E, F. We'll wait for a request. Okay, E's been chosen. N to the 2/3 plus 5n to the 1/3 plus 6 equals 0. All right, so for this problem, we're trying to solve this equation. It's not quite a quadratic, right? It's not quite, because it's got fractional powers. So this is the one where we have to kind of like squint our eyes and notice something. The big thing to notice is that this n to the 2/3 can be rewritten as n to the 1/3, but then squared. We have to realize that. And if we realize that, then this is n to the 1/3 squared plus 5 times n to the 1/3 again, plus 6 equals 0. And now it looks a lot like a quadratic if I make a substitution. The substitution that I want to make is I'm going to let u be equal to n to the 1/3. And if I do that, then the equation becomes, this becomes u squared plus, and then 5 times that n to the 3rd power, n to the 1/3 power becomes u, and then plus 6 equals 0. See, I've converted this equation from something that wasn't quadratic into something that is quadratic. And now I try and solve this. And I'm going to hope that I can do AC. I think it works. 1 times 6 is 6. And then I have 5. And the 2 numbers that, why don't somebody give me those 2 numbers? This one always gets people, because so many people want to do 6 and 1. It's not 6 and 1. What is it? In this particular case, it's not 6 and 1.
2 and 3.
2 and 3. Good. 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. All right. So this is going to be u plus 2, u plus 3 equals 0. Set each of those equal to 0. You get u is -2. And you get u is -3. We're not done. Because what was u? U was n to the 1/3. So you replace u with n to the 1/3. And now we have to solve for n. So we see a 1/3 power there. We want it to be n to the first power. So we are going to cube both sides. We'll do that here as well. The cube will get rid of that 1/3. It'll turn into just n. And then on the right, we just do -2 times -2 times -2. That's -8. That's one answer. Same thing over here, cube the left side, and the right side, -3 times -3 times -3 is -27. We do not need to check those answers because we never raised anything to an even power. We only did odd powers. Questions here? No? See what else we got. Yikes. Solve and check your answers. A, B, C, D, E. Okay, what do y'all want? All right, D has been chosen. I'm gonna write it over here because I'm probably gonna need some room. Y squared plus 7y plus 12 equals y over y plus 3. And then plus 5 over y plus 4. All right, we need to solve this equation for y. So what I'm going to do first is I'm going to try and get rid of all these fractions because they're just a mess. So I want to multiply both sides of the equation by the LCD. But before I do that, I should probably try and factor this denominator. So on the side here, what I would do is try and do y squared plus 7y plus 12. I do my AC method, 12 here and 7. And I get the numbers 3 and 4. So I'm trusting you could do that. You would get y plus 3, y plus 4 here equals y over y plus 3 times y 5 over y plus 4. So now when I'm considering my LCD is I'm going to need a y plus 3, and I'm also going to need a y plus 4. I'm going to need both. So what I do now is I take this, I'm going to cheat here because I don't feel like writing this down again. I guess I'm not going to cheat. It's not going to let me do it. Won't let me grab it. Oh, there we go. Okay, so I'm going to take this. And I'm going to multiply both sides of this equation by the LCD, which is y plus 3 times y plus 4. Do that over here. do that over here. Okay, on the left-hand side, nice things happen. They just cancel completely. You just get -5. On the right-hand side, you have to distribute this here and then this here. When you do the first multiplication, right? When you do that first multiplication, the y plus 3 cancels with this y plus 3 on that first multiplication. So what you're left with is the y that was on top and then the y plus 4 that didn't cancel with anything. On the second multiplication, here to here, on the second one, the y plus 4s cancel and you're still left with the 5 and the y plus 3. So you should have here plus the 5 and then the y plus 3. So that's it. We've cleared the fractions. Now I'm just going to clean this up. Distribute. So -5 equals, let's see, y squared plus 4y plus distribute 5y plus 15. That's -5 equals y squared, combining like terms. And now bring everything over to one side because this is a quadratic. Adding 5 to both sides, I get that nice quadratic. I'm going to hope for the AC method here. 20 and 9. 20 and 9. 5 and 4. 5 and 4. Multiply to be 20, add up to be 9. So this becomes 0 equals y plus 5, y plus 4. Set each of those equal to 0. You should get two answers, -5, and the other answer should be -4. Now, we have to check our answers because it is possible, because our original problem, see that there was y's in the denominator. Actually, probably be best to look at this one right here. Do y'all see if I look at that? Let me try my two answers in there. If y is -5 or y is -4. -5 is no problem. If I plug -5 into the bottom here, or here, or here, or here, I don't have an issue. But I definitely have an issue if I try and plug -4 in. If I try and plug -4 in right here, I have an issue. Or here, because I'll get zeros on the bottom. And I can't divide by 0. So that means when I'm considering my answer, I'm going to throw out this one. The only answer I have is -5. Okay, I hope that helps. Let's see what else we got. All right, what would y'all like to see? Well, see, right? Yeah, that's the one I would have picked too. I would have picked C or F because they both have negatives in front. So, all right, here we go. -5 square root of n minus 11 plus 4 equals -21. Okay, this is a radical equation, right? You see the radical in there. We're going to solve this radical equation. To do that, we're going to try and isolate this, get it by itself. The first thing I'll do to get it by itself is I'll subtract 4 on both sides. Okay, I've added, subtract 4 here, subtract 4 here. So now I have -5 square root of n minus 11 equals, okay, that's negative 25 there. Now I will divide both sides by -5, trying to get that root by itself. That gives me root n minus 11 equals, that's just 5. This turned out to be pretty straightforward. Square both sides to get rid of the square root, and I know now I'm gonna have to check my answer. If I have 2 answers, 1 answer, doesn't matter, I'm gonna have to check it. So now n minus 11 equals 25. And I'll add 11 to both sides. Oh, how nice. 36 is my answer. But I need to check it. So let's check. And when I check it, I need to check it into this equation right here. So -5 square root of 36 minus 11. And then I have +4. Does that equal -21? Okay, this is -5 times, let's see, 36 minus 11 is 25, and then +4. Does that equal -21? Well, the square root of 25 is 5, so that's -5 times 5 plus 4 equals -21, does it? Let's see, that's -25. Order of operations, I have to do that multiplication. Wait, why did I put 21? I have to do that multiplication before I do the addition. And yeah, in fact, that does work. So that solution is correct. I've had students ask me before, nobody's asked me here, but I've had students in the past ask me, like, hey, I realize that when I square both sides, I have to check my answers, right? But they say, hey, if I only have one answer, then doesn't it have to work? You know, like if you have 2 answers, yeah, maybe it makes sense that one of them wouldn't work. But if you only have one, does it have to work? And the answer is no. Okay, you have to check it because it could be possible that it doesn't work and then there's no solution to the equation. All right, so always check. Okay. Now we move into quadratics. The rest of the problems all have the same directions. And let me see down here. Let's see. Yeah, we're not going to do this. Yeah, let me just double check the rest of this. A lot more on here. We're not doing all of this, okay? Okay, so the next set of questions, 7, okay, the next set of questions here, they give you a quadratic and then they ask you some questions, all right? I'm just going to pick one of these. I'm just going to do one. Let me just do this one. I'm going to do just the first one, okay? That way it'll be easy for me to. So the thing about this problem is that it's actually asking us to do a couple of things. Some things we've done recently and some things that we did in the past, all right? So this might be a little bit tricky, all right? So you have this quadratic function, f of x equals x squared minus 8x. Please pay attention to this problem because I just have this feeling students are going to struggle with this one. All right, the first thing they want is the domain, and then they want the range of this function. Well, we know right now that this is a parabola and that it opens up, right? We know that because the a in front is 1. So all we really need to do is find the vertex. If we find the vertex, then we'll know where it starts going up from. So to answer parts A and part B, what I'm going to do is I'm going to find the vertex. How do we find the vertex? Well, I just gave you the formula today. H will be negative b over 2a, which for us would be negative -8 over 2 times 1 So that's 8/2, which is 4. That's the first part of the vertex. And now to get k, what I do is I take that 4 and I plug it into the function. So we get 4 squared minus 8 times 4 minus 7. That's 16 minus 16 minus 7. No, sorry, not 16 minus 16. 16 minus 32 minus 7. That's negative 16 minus 7. That's negative 23. That tells me that my vertex, right? My vertex, this point right there is the point for negative 23. That means to the left 4, down 23. I can now tell you the domain and range, right? Because I know it's like this. I go to the right 4, I go down 23, put a point, and it opens up, right? Like that. So for part A, the domain of this, of course, it's a quadratic, the domain is everything. For part B, the range is everything from negative 23 on up. Any questions on that first 2 parts? Look at part C. All right. True or false? The function has 2 imaginary roots. Well, look at your picture. Is your graph going to hit the x-axis? These are called the roots of the function. Do we have 2 answers that are real numbers, or do we have 1 answer, or do we have no answers? Well, in this case, we have 2 real number answers, right? Those are 2 numbers on the x-axis. So it is false. It is false that we have imaginary answers. Here's how you would know you have imaginary. If our graph looked like this, then the answer to that part C would be true, because you know from this that you don't have 2 x-intercepts. So if you were to use a quadratic formula, you would get a negative underneath that root, which means you had imaginary answers. All right, any questions on these first couple? Now let's look at D. For D, we're being asked for what value of x is f of x equal to 13? What they're saying to us is, what value of x do we plug into this function to get it to spit out a 13? That means I need to take the function and ask myself, when is that equal to 13? I take the function and set it equal to 13. And this is a quadratic equation. So you have to solve this equation. So I would now subtract 13 on both sides to get everything over to one side. And once I'm there, I can try the AC method, or I can do what you always have, quadratic formula, don't you? But I think AC is going to work here. 1 times negative 20 is negative 20, and the middle number is negative 8. And the 2 numbers that do that are negative 10 and 2. Negative 10 times 2 is negative 20. Negative 10 plus 2 is negative 8. So this becomes x minus 10, x plus 2 equals 0. You set each of these equal to 0, and you get your 2 answers, positive 10 and negative 2. So what we're saying is, if you plug 10 into this function, it's going to spit out 13. If you plug a negative 2 into the function, it's going to spit out negative 13. I'm sorry, it's going to spit out 13. All right, any questions on that part? Actually, I'm going to copy this. I'm going to move it down because I'm running out of space. I'm going to go to a new page. Maybe not. All right, so we're on now on E. For part E, they're not asking when the like on the previous one, they said, when is the function equal to 13? That's not what we're saying here. Here they're saying, what happens if you plug 1/2 into the function? That just means replace all your x's with 1/2. So 1/2, take that, square it, minus 8 times 1/2 minus 7. So just plugging a number into the function. 1/2 squared is 1/2 times 1/2 is 1/4. Okay, half of 8 is 4, and minus 7. This is 1/4, take away 11. Putting the minus 4, minus 7 together. Now you need a common denominator. 1/4, take away, look at 11 as 11 over 1, multiply top and bottom by 4. And now you get negative 43 over 4. Just doing 1, take away 44, negative 43. And the question's there. For F, we want to know what happens when you plug negative x into this function. So just go everywhere you see an x, replace it with a negative x. Okay, this first part, when you take a negative x and you square it, it doesn't matter that it was negative. It's just going to turn out to be positive. And then on the second part, you have negative 8 times negative x. That's now positive 8x. And then minus 7 doesn't change. So that's it. That's all they wanted you to do right there. Just plug negative x into the function. Notice that when we plug in negative x, we don't quite get back the same thing we started with, right? Those two are not exactly the same. They're a little bit different. All right, last part, G. G is find out what f of x plus h is. And if you ever take Cal 1, which most of you are going to try and do that, you're going to have to plug x plus h into functions all the time. It's really going to be a skill that you need to know. So I'm replacing the x with x plus h. I'm going to the original function. Everywhere I've seen x, right? Everywhere I've seen x, I'm replacing that with an x plus h. And now what I'm going to do is, I'm not going to say I'm done. I'm actually going to figure out what this is. So this right here turns out to be x squared plus 2xh plus h squared. I get that by doing this. I'm not going to show the work, but I'm squaring it, so I have to FOIL and collect like terms. If you do that, you get these 3 terms. Then I distribute minus 8x, minus 8h, and then minus 7. Nothing collects together. There's no like terms there. So that's your answer. Okay, so we're done with this problem. There was a lot of kind of weird things. We're bringing a lot of things together here on this problem, right? You have to be able to figure out what the graph kind of looks like so you can get the vertex and figure out the domain and range. You have to understand the idea of whether or not you have roots or x-intercepts by looking at that graph. You've got to be able to set the function equal to a number and solve a quadratic equation. And then you have to be able to evaluate the function at 3 different values: a number, negative x, and then x plus h. So you've never seen a problem like that. Well, that's what I'm getting at. Like, I've never given you a problem exactly like this one. It's kind of a lot of different ideas together. So there's another couple of these for you to practice. You see all those? Okay. All right, now let me, because we're running out of time, let me tell you what else would potentially be on this test. So there's 8. Let's look at, we're not gonna do anything on 8. Let me see, 9. If I gave you one of these for 9, oops. My instructions here for these, the instructions here would be, here's some quadratic functions, and I'd ask you to do exactly what we did earlier today with this. I'm not going to have time to go through another one of these, but we did a few of these today, right? So here's a function. Does it open up or down? What's the vertex? Sketch it, axis of symmetry, x-intercept, domain and range. I will give you a problem from that list right there. All right, it'll be one of these, and I'll ask you to do that. I'll put that back up in a minute. Let's see what else we got. Okay, these are going back to earlier problems, exponent rules. So I'm going to have you're going to have to review this one on your own. I don't know if I've only got a few more minutes. But I will give you, something from, so number 9, one of those. Number 10, one of those. So this, you got to go back, and this is simplifying complex fractions. And then this is more fractions, adding and subtracting fractions, getting common denominators. And then number 12, this is complex fractions. And number 13, we already talked about. So I'm going to say off this review, let me kind of back up. I'm going to write this all down. Pen. So on this review, you'll definitely have something. One of the problems from number 1, one of the problems from number 2, 3 and 4. 5 and 6. 1 like 7. Nothing like 8. And then I think we're going to do 9, 10, 11, and 12. Yeah, 9 through 12. 7, 9, 10, 11, 12. So off of that document, I promise I'm going to give you one problem from each of those groups. Does that make sense to everyone? So, I mean, you already have a bunch of problems from your final in front of you. It's just a matter of, are you going to take the time? I mean, we only have 24 hours, less than 24 hours. Do you have enough time to go back and review and do some of these? But there's going to be no surprises as to what type of problem you're going to see, right? It's just a matter of, can you actually follow through? In addition to those, right? In addition to those, the only other thing that I would expect that you can do is the stuff we talked about right before this one, right? It was numbers, where did it start? It was off of this other document. It was number 15 through 25, right? Does that all make sense? Do y'all have any questions? Any questions at all? Okay. If there are no questions, I'm gonna say it's a wrap, but I'm willing to hang out and do another problem, one of the ones I didn't do, 9, 10, 11, or 12. So in the chat, if you want, you can make a request right now, which of these you'd like me to do. 9, 10, 11, or 12. Any requests? Well, okay. Yeah, 12 looks good. Any requests out of those in terms of A, B, C, D, E, F? They all kind of look the same. Maybe not. They're all very similar. So I don't think it would really matter which one of these I do. Let's do E. Let's do that one. I'm going to copy this whole thing because I want to be able to get back to this later. All right, this will probably be the last problem I do. All right, so here we go. I've got n plus 10 over 20n all over n over 20 minus 5 over n. When you go back and look, if you look in your notes, we actually did these two different ways. So I'm just going to do it the way that I did it the first method, which is to first realize that I've got two fractions here that I can put together, right? I can put those together with a common denominator. To put a common denominator, I have to multiply this top one and bottom one by n, and multiply top and bottom here by 20. And that way they both have 20n in the denominator. This becomes n plus 10 over 20n over, okay, when I multiply here, I get n squared. And then minus, now 5 times 20 is 100. And then over the common denominator, which was 20n. That's the first step, get a common denominator on the bottom. The next step is to look at the fact that I have a fraction being divided by another fraction. So I can do that whole keep dot flip. I keep the top fraction and I change the division into multiplication, but I flip the bottom fraction over. And that's really good because the 20n's can now reduce out. And then I'm left with n plus 10 over n squared minus 100. And this is almost done. You now have to recognize that the denominator is a difference of squares. See, if you don't see this step right here where you've got a difference of squares, n squared minus 100, then you miss this thing, canceling. And when those canceled, you have still a 1 on the top, and on the bottom, the n minus 10. Don't say that this is n minus 10. That's not right, right? It's 1 over n minus 10. There you go. Okay. That's it for that one. Any questions on that? All right. And then, you know, on this one, you just get a common denominator, multiply top and bottom by something, put them together. This one, keep dot flip. And there's a lot of factoring going on here. A bunch of things will cancel. So you got a bunch of like AC method and differences of squares in there. All right, everyone. I want to say thank you specifically, Salvador, Brianne, Saif, Joseph. You're the ones who have had your cameras on for a majority of the time. I know others have turned them on and off, but I know your faces. I really appreciate it. I did require at the beginning of this class that everyone have their cameras on for 85% of the time. There's only about 4 people in here that actually adhere to that. And that group will be rewarded with a bonus on the final that will really help you, because I didn't want to have to babysit y'all and tell y'all every day, turn your camera on, turn your camera on. And all of you did it without me asking. So I appreciate that, and you'll be rewarded for that. Otherwise, I'll see y'all tomorrow. Everybody have a good rest of your day. And if you have any questions between now and tomorrow morning, then I will be available via text on my cell phone, or you can email me. All right. Good luck studying, everyone. See you tomorrow morning.